This is Mr. Martin. These are the video notes for Precalc Honors. This is section 9.3, video number 2. We got to continue talking about hyperbolas. So what we need to do now is talk about the asymptotes of a hyperbola. Because you probably know what a hyperbola looks like, and the two pieces, the two curved pieces that make up the hyperbola, they approach asymptotes that we're going to need to know the properties of and how to use them and how to find them. So first let's take a look at horizontal transverse axis. So let's just make a sketch here. So here's my axes, and then I'm just going to draw in a, let's mark this off as a negative A, and let's mark this off as positive A, and we'll have B over here and negative B over here. And then when you're drawing your hyperbola, the best thing to do is locate this rectangle based on your values for A and B, and then draw in your diagonals. These are going to be our asymptotes. Notice that these are dotted because they're not actually part of the hyperbola. They just help us to draw it. So here's my asymptotes. And then if I want to draw in the curve, this is a horizontal transverse axis, so notice A is on the x-axis. So I'm going to draw in a curve that approaches the asymptotes over here and approaches the asymptotes over here. Okay, so the form that I have my asymptotes, notice I have y is equal to k plus or minus b over a times x minus h. And then if I move that k over to the other side, it would be y minus k, which is exactly what we've been seeing in circles and ellipses and so on. So notice the difference between horizontal and vertical is that over here the slope, this is our slope of the asymptotes, is b over a, but over here my slope is a over b. So let's just take a look at this slope that has this asymptote that has a positive slope. Remember, slope is rise over run. So if I look at the rise, that's b, and if I look at the run, that's a. So the slope here would be rise b over run a, which again is going to match with us here. So if you know which way it opens, you can use your a and your b to help you determine whether it's supposed to be b over a or a over b, and then you don't really have to worry about memorizing which one goes with which. If you prefer to do it that way, go right ahead. I always just figure it out this way, knowing a and b, know which way it opens, and then I can figure out my rise over my run. Alright, so let's take a look at for a vertical transverse axis. So now I'm going to have some value a over here, some value negative a, and then I'll have a b and negative b. Again, I can draw in my rectangle, and then I can draw in my asymptotes. So there's one asymptote, there's the other asymptote. Again, notice that they're dotted because they're not really part of the graph. And then using my rectangle and my asymptotes, I can draw on the curve. So we'll approach the asymptote over here, approach the asymptote over there. Notice I'm right on the vertex at A. Okay, and again, if I'm looking at this positive asymptote, the slope is positive here, I'm going up A, that's my rise over here, and over B, that's my run over there. So hopefully that'll help you remember, you know, over here slope is B over A, over here slope is A over B. Again, anytime you have questions, make sure that you pause the video and ask me if you're watching in class, or write them down so you can ask me later. So let's sketch the graph of the hyperbola whose equation is 4y squared minus 9x squared equals 36. So we're going to put this in standard form. So in this case, there's no completing the square that needs to be done. This is going to have its center at 0, 0. So we've got 4y squared minus 9x squared, and that's 36. Our standard form has to equal 1. That's why I'm dividing by 36 here. So then we get y squared over 9 minus x squared over 4 is equal to 1. So my y squared is first, so this means it's going to be vertical. Okay, this is going to be vertical. Okay, a and b don't switch, so a is going to be equal to 3, and b is going to be equal to 2. So square root of 9 is 3, square root of 4 is 2. That gives me a and b. So I can start locating my vertices. So I've got 3 up, because it's vertical, and 3 down. So there's my vertices, and then I'm going to go 2 to the left and the right from the center, which is at 0, 0. And then I'm going to draw on my rectangle. And from there I'm going to draw on my asymptotes that go through the opposite vertices of my rectangle. And once I have that drawn in, and quizzes or tests, any kind of assessments, I'm going to expect to see all these parts again dotted, except for the curve, which I'm about to draw in. So start at my vertices, approach my asymptotes, do the same thing down here. Okay, so that's the graph. This is my standard equation over here. I could find foci if I wanted to, just for fun. We'll find the foci. So we need to find c. We know c squared is a squared plus b squared, so that's going to be 13. So c is the square root of 13. So then my foci, I'm going to go up and down. So I'm going to be at 0, comma 13, positive and negative square root 13 if we wanted to find foci as well. So that would be square root of 13. That's going to be between 4 and 5, or 3 and 4. Sorry, 3 and 4, 1, 2, 3. So somewhere, they're going to be somewhere in here. Okay, again, if you have any questions, make sure that you ask. Number 3, we want to sketch the hyperbola and find the equation of its asymptotes. So we're going to have to put this in standard form. So notice that we only have the 9x squared term, but we have some other stuff here. So we're going to have to do some completing the square to get this into standard form. So, and with a hyperbola, you really have to be careful with the signs. So I'm going to have 9x squared minus, and then my leading coefficient has to be 1 here. So I'm going to factor out a negative 4 times y squared minus 2y, because I factored a negative 4 out of there. And then plus, I'm going to complete the square in here, and then move that 40 over to the other side. Alright, so I'm going to take half of negative 2, so that's negative 1. And over here, I'm subtracting negative 4 times negative 1 squared, so I have to subtract 4 times negative 1 squared over here so that it matches. Be careful about that negative 4 that we factored out. Make sure you include it. So then I have 9x squared minus 4 times y minus 1 squared. That's what this all factors to. Is equal to 36. We want it to equal 1, so we'll just divide both sides by 36. So I get x squared over 4 minus y minus 1 squared over 9 is equal to 1. So horizontal or vertical, I see that my x squared is first, so that means it's horizontal. A squared is 4, so that means that a is 2. B squared is 9, so that means that b is 3. And I can start to graph this now. So it's horizontal, so I'm going to go 2 left and right. Let's get my center in there first. So I've got the center is going to be 0, 1. 0, 1. So let's draw my center at 0, 1. And then I'm going to go 2 units left and right. So 2 units there to get my vertex on the right, and 2 units there to get my vertex on the left, and then 3 units up and down from the center. And then 3 units down. Everything's always from the center. I'm going to draw in my rectangle. Draw in my asymptotes, which we're going to find the equation of in a moment. Here's my second asymptote with a negative slope. And then I can draw on the curve. Again, it's horizontal. So these are my vertices here. There's the one vertex on the left. Here's the other vertex on the right. So there's my sketch. And now I just need to find the equation of the asymptotes. So this distance was b, so I went up b units and over a units. So my slope is going to be b over a. So for my asymptotes, I've got y is equal to k plus or minus b over a times x minus h. So I've got y is equal to k, which was 1, plus or minus b over a, which is 3 over 2, times x minus 0, so just x. Okay, and there's really no need to simplify these. You could just leave it right like that. Again, if you have any questions, pause the video, write them down so you don't forget. Let's move on to the next problem. We want to find the standard form of the equation of the hyperbola having vertices 3, 2 and 9, 2, and having asymptote y equals negative 2 plus 2/3 x and y equals 6 minus 2/3 x. So I'm going to go ahead and pause the video here if you want to do that as well and see how much you can get on this, and then when you come back we'll have the solution. I can discuss it. Alright, so here's the work for the solution. Here's my equation. And really what I started with is I started with a little sketch. So I sketched out the vertices 3, 2 and 9, 2, and since my vertices were horizontal, I knew that my hyperbola also had to be horizontal. And I also knew that the center had to be halfway between my two vertices. So my midpoint, the x-coordinate of the midpoint anyway, is going to be 3 plus 9 divided by 2, or 6, so that I know that my center is going to be 6, 2. So that's my HK. And really the only other thing I need to do now is find B. So I know that A is going to be 3 units. That's my distance between the center and either of the vertices is 3. But then my slope is 2/3. And I know for a horizontal hyperbola, the slope is going to be b over a, so that since a was 3, I knew that b would have to be 2. So here's a and b, and once you have that, you just substitute a and b in. So here's my a squared, here's my b squared, here's my h, and here's my k. Make sure you put in a minus since it's a hyperbola. And there's the equation of your hyperbola. Okay, I'm going to stop this here, and I'm going to have a very short video on the last page, so if you want to just go right ahead and start watching that way. That'll be video 3. And again, if you had any questions, let me know, and we'll see you next time.